Hello everyone, welcome to this course on From Zero to Hero in Trigonometry. So I guess so far from the previous lessons you have a fair idea about the basic idea about trigonometric ratios. I just want to warn you that when you say sine of A, when I write sine A, this is basically an abbreviation for sine of angle of sine of angle A. Okay, it's not like you're multiplying sine with A. Okay, in general, you know that if I write A, B, it simply means that A is multiplied with B, or if I write X, Y, it simply means that X is multiplied with Y. So here in this case, it should not be interpreted as the multiplication of sine and A. In fact, simply writing sine does not make sense. This sine separated from A does not make any sense. So sine A is basically a short form for sine of angle A. You can also say that suppose this is a black box, and if you feed A to this as input, if it gives sine A, okay, you can think of this as an input output relationship. We call such relationships as functions, and soon we will be able to represent these trigonometric ratios as trigonometric functions. We'll soon see that. But for the time being, you can understand that this is like sine is like a black box which takes in an angle as the input, and then it gives a number as the output. For example, if you feed 30 degrees to this, the output will be 1 by 2. If you feed 45 degrees to this will give me 1 by root 2 and so on. Okay. So if you feed any acute angle to this black box, it is going to give me a number. So that's basically a relationship between an angle and a number. So that's about sine, and similar interpretation will follow for other trigonometric ratios as well. Now we are going to talk about trigonometric identities. So we already know like what an identity is. For example, x plus y whole square is equal to x square plus y square plus 2xy. This is basically an equation, but this equation is true for all real values of x and y. So this is what we call an identity. This is in fact an algebraic identity. Now when we come to trigonometric identities, an equation that involves trigonometric ratios, but that is true for all values of the variable, is what we call a trigonometric identity. So let's see some of the most popular trigonometric identities. For that, let's consider a triangle. So I have a triangle. This is angle, this is vertex A, this is B, and this is C, and this is small a, this is small b, and this is small c. And if I call this angle A as theta, now using Pythagoras Theorem, we have a squared plus c squared is equal to b squared. So this is our Pythagoras Theorem. Now what I'm going to do is I'm going to divide this entire expression with b squared. So I'm going to divide the entire expression with b square, and let's see what happens. So we have a squared by b squared plus c squared by b squared is equal to 1. And from this, you can see that a by b is nothing but, as far as theta is concerned, a by b is nothing but the ratio of the opposite side by hypotenuse. So this is a by b whole square, which is sine squared theta. Again, I just want to remind you that when you multiply sine theta with sine theta, or basically when you're squaring sine theta, when you square sine theta, you write this as sine squared theta. So this is the notation that we will follow, right? And similarly, when you take reciprocal of sine theta, we are going to write it as sine theta raised to minus 1, and we won't write it as sine raised to minus 1 theta. This we will not use because this stands for some other notation. This is what we're going to call as the inverse trigonometric function for sine, inverse sine function, sine inverse of theta. So this is a different notation, but for say sine theta whole squared, we are going to use this notation. So when I write sine power 2 theta, it simply means sine theta the whole squared. And similarly, the next expression is going to be c by b whole squared. You see that as far as this angle theta is concerned, c by b is nothing but the ratio of the adjacent side to the hypotenuse. So that is going to be cos theta squared equal to 1. So this is the most important identity from trigonometry. It's nothing but the Pythagoras theorem that is disguised in terms of trigonometric functions. I mean trigonometric ratios. And since theta can be any value, this is true for all values of theta, and this is a trigonometric identity. Alright. And similarly, so if we begin with Pythagoras theorem, a square plus c square is equal to b squared, and then if instead of dividing by b square, what happens if I divide it by a square? Let's see. If I divide it by a square, divide by a square, not on just one side, divide it on both sides. So we have 1 plus c squared by a squared is equal to b squared by a squared. Again, from the figure, you can you know that c by a ratio is nothing but cot theta. So this becomes 1 plus cot squared theta is equal to, and b by a ratio is nothing but the reciprocal of a by b, reciprocal of sine, which is cosec, square theta. So this is another trigonometric identity which you need to remember. And again, instead of dividing by a square or b square, let's divide by c square too. Let's begin with the Pythagoras theorem. Now we divide the entire expression with c square, divide by c square, and what happens? We have a square by c square plus 1 is equal to b square by c square. And a square by c square, what is a by c ratio? It is tan squared. So tan squared theta plus 1 is equal to, what is b by c ratio? B by c ratio is the reciprocal of cos, which is sec squared, sec. So we have a square here. So 1 plus tan squared theta is equal to sec squared theta. So these are the very basic trigonometric identities that you need to remember. In fact, it's nothing but Pythagoras theorem disguised in the form of trigonometric identity. So do not forget that. And I'll also give you some more identity. So in this case, again you consider the same triangle. So this angle is going to be 90 minus theta. 90 minus theta. Now you see that if you take sine of angle C, which is 90 minus theta, that is going to be the opposite side by hypotenuse, but for 90 minus theta, the opposite side is angle C. So this is going to be C divided by B. And don't you recognize this as cos theta? Yes, that is cos theta. Similarly, if you take cos of 90 minus theta, as far as angle C is concerned, the adjacent side is A and the the hypotenuse is B. So A by B ratio, which is nothing but sine theta. Similarly, you can have tan of 90 minus theta. Tan of 90 minus theta is going to be C by A ratio. This will be cot theta. Now, if you take reciprocals everywhere, you get the corresponding results for the reciprocal trigonometric ratio. So cosec of 90 minus theta is going to be b by c, and that will be sec theta, and sec of 90 minus theta is going to be b by a, which is cosec theta, and cot of 90 minus theta will be a by c, that will be tan theta. So we have learned a set of 3 trigonometric identities here, another set of 3 trigonometric identities here. So these are what we call trigonometric ratios of complementary angles. Okay, theta and 90 minus theta are complementary angles. So how the trigonometric ratios of theta and 90 minus theta are related? So that is given by these 6 trigonometric identities. Okay,